Hi, my name is Anna Kummer, and today I'm presenting my DSARI Home Energy Audit Project, where I measured the energy use of 8 devices and tracked energy usage for a full week. For some background information, I currently live in Mark G. Udoff Hall, which is an on-campus apartment, and it has 2 bedrooms, 1 bathroom, a kitchen, and a washer-dryer, and I live with 3 other roommates. And the rough square footage is 560 square feet. I had to run a few calculations to find the average electricity use per month and annually. And so the average electricity use is 0.875 kilowatt hours per square foot monthly, and then I multiplied that by 560 to get 490 kilowatt hours per month, and then I also multiplied that by 12 to get the annual estimate of 5,880 kilowatt hours. And then a typical utility bill would cost about $150 to $250 for an apartment of this size. For my estimated energy use breakdown, I looked online and found that heating and cooling takes up a majority of the amount of energy use, coming to 45%, followed by laundry and water heating with 15% each, and then the 3 lowest being lighting and electronics, kitchen appliances, and then smaller appliances and miscellaneous items. For additional background information, I also listed the average electricity use for each of my devices in watts. And then moving on to the audit process, here I have 8 images of my kilowatt meter measuring the watts and kilowatt hours of all of my 8 devices, including the LED bulb. And then this is my daily log where I measured how many hours I used each device, and I accurately measured this by writing down what time I started and what time I ended on my notes app so that I could get an accurate number. And I found that my air purifier was on the longest because it remains on 24/7. For quantification, these are 2 tables representing the constant power devices and variable power devices, and it shows the watts per day on, watts per day off, the total watts per day, kilowatt hours per day, and kilowatt hours per month for all 8 devices. So to calculate constant power device calculations, to get watts per day on, you would multiply watts on times hours per day on. And then for watts per day off, you would multiply watts off times hours per day off. And then to get watts per day total, you would add those 2 calculations to get your total. For variable power device calculations, I needed to find the watts average and the watts per day total. To find the watts average, you would divide kilowatt hours total divided by total hours, and then you would multiply that all by 1,000. And to find the watts per day total, you would take that watts average number and multiply it by 24 because there are 24 hours in a day. For my light calculations, I had to find the wattage of the light bulb times the hours per day to get the watts per hour per day. And for my light, that was 3.5 times 1.25. For my key takeaways, I found that my total kilowatt hour per month was 9.66, and that is significantly lower than the average number that I found online for an apartment of my size, where it comes to 490 kilowatt hours. And this shows that I measured primarily low energy user devices and not the high energy user devices. The high energy users are likely the washer, dryer, refrigerator, and microwave. And also I want to state that this audit did not include or account for the energy of heating and cooling, which is likely a significantly large number because that was the largest percentage found in my estimated energy use breakdown. And for the total energy measurements comparison, my total apartment monthly consumption is 9.66 kilowatt hours per month, and the estimated monthly energy consumption for a 560 square foot apartment is roughly 361 kilowatt hours per month, and that shows that the audit that I measured is way lower because I only measured the low energy users. And here I have a table of a comparison from the wattage I found in my audit compared to the wattages I researched online of my 8 devices, and I found that the hairdryer for both the audit and the researched online was the highest number. Lastly, for ways I can improve and save energy, I specifically focused on my desk lamp, and I said that I could unplug it when it's not needed, and it's roughly plugged in for 18.75 hours per week. So if I reduced my desk lamp usage by 50% by turning it off when I didn't need it, I would save 9.37 hours, and that would save 27.08 watts per day. Here I have a list of my references. Thank you for listening.